Following on and using what we've done so far plus something new, if we have 4 and we square root it, we know that that is 2. In that, 2 times 2 is equal to 4, or another way of writing it, 2 squared equals 4. Oh, by the way, another way of writing that is this. Put a bracket around it. Okay, so that tells us it's the root, square root. So if I were to do this, that's the cube root. If I were to do this, it is the 27th root. You're not likely to come across that. You know, that would be written as 4, like that, with 27 in there. That one is written as 4 cube root, and this one we tend to not put any number in there, but you can if you want, but it is not normally done. Okay, so we are talking about this type of situation. Okay, so what we're looking at is square root of 4a remove 5 equals 5. Now, without the equals 5, this is an expression a can take on any value we want. Because we've done that, it fixes the value of a. How do we get rid of this root? Well, we square both sides. So let me put that in a bracket. There's the square root of 4a minus 5. Take that across there. Close. Now I want to square that. Equals. Because I've squared the left, I have to square the right. So we know that 5 5s are 25. This process removes the square root, so we end up with just 4a minus 5. Now, using the shortcut, take the 5 over to the other side, equals 25. There we are, we've moved the 5. Now look at the sign. It is minus here. Over the other side it becomes plus. And we're just left with 4a. So we have this lot here is equal to 30. So we have 4a is equal to 30. Want a on its own, so we need to get rid of the 4. The 4 is multiply. Take the 4 over the other side, it becomes divide, which is the same as multiply by 1 over 4. Okay, so a is equal to half of 30 is 15. Divide that by 2. Yes, so it is in fact 15 over 2. Yes, my brain's not working very well. Okay, let's substitute that back in and see if it works. We have, now I'm going to put the bracket, 4 times the new value of a, which we reckon is 15 over 2, close bracket, minus the 5, and we want the square root of the whole thing, and that equals, hopefully, 5. Alright, let's work this out. That cancels out, that becomes 2, so that's 2 times 15 minus 5 square root of, that is 30 minus 5 square root of, which is the square root of 25, which indeed equals 5, which is that. There you go. Straightforward. Just so you get used to the idea of the system, let's do another one. I've no idea how this is going to work because the numbers are made up on the fly. There's a new phrase for you. Let's hope I don't make a mistake. I really want this to work. I really want this to work. And there's a little line in the middle separating the board into two parts. What should we go for? Let's go for square root of, I don't know, 36 minus 7. Awkward numbers. Oh, what am I doing? I forgot to put in the variable, didn't I? It's called a variable. The unknown thing is called a variable because it can change. Let's go for 26. Right, now this will probably end up with very awkward fractions. Fractions are precise. Decimals, not always so. Right, we want to, and I'm going to use a calculator on this one, we want to get rid of the root. So we square both sides. So we end up with that squared. So we have bracket 36a minus 7, and the whole thing is squared, equals 26. The whole thing is squared. That would give me 36 times a minus 7 equals, now let's call up my calculator, and we have 26 squared, 26 squared gives me 676. 676. Thank goodness for calculators, eh? Right, okay, we want the 7 over the other side, so we have 36a. Let's move the 7, 676. There's the 7 we moved. Now we check the sign, negative, so the other side it becomes positive. So we end up with 36a equals 2 7s are 14, so it's 1386. We want a on its own. The 36 is multiply. Take it over the other side, it becomes divide. Or if you like, you can do that. Take it over to the other side, and the 36 over 1 is turned upside down. A equals 683 times 1 over 36. See, if it's multiply, take it over the other side, turn it upside down and multiply. And what does that give me? That gives me, okay, so let's have a look at that. We've got 683. Divide that by 36 and we get that as a fraction. A 683, well, probably means it doesn't divide very well, and oh, as a decimal that becomes, let's keep it at yeah, right, what was it, 1897.97, and my calculator, when it does what it did, means 2, 2, 2, and they go on forever. As soon as you round that, you introduce an error. So really an exact answer is 683 all over 36 as an exact answer. This is not exact. Does it work? I hope so. Let's have a look. Putting it in a bracket, we have 36 times the value of a, which we said was 683 over 36. And we wanted the square root, oh wait a minute, minus 7. Now it's correct. Equals 26. We hope. Let's see. Those two actually cancel out. So we want the square root of 683. Yes. Oh, please work. Please work. Okay, we have, I'll do it as a fraction. Shall I do it as a fraction? Those cancel out. Got to subtract the 7, never mind. No, 6, 8, 3. Remove the 7, gives me that. Right? Now, the odd thing about this, it's got an answer button, which means it will use that. If I go square root of answer, it gives me 26. So all that lot there becomes 26, which indeed does equal 26. So the method works. I've got it right. Whee! Okay, so square the left to get rid of the brackets, square the right because you've already squared the left, and do your calculations. The principle is quite straightforward. Sometimes actually doing it can be a bit of a challenge. It all depends on the numbers you get.